Thank you everyone for the attention. This is my work research, and I will show you a little bit about the analysis of lighting protection of wide turbine blade. Uh, in different parts of the world, wide generators are commonly installed in open fields, and to use the strong winds, they can have different heights. Even so, they become constant targets of light. It's important to note that the repairs to these generators are extremely expensive, and that is why their protection is of a paramount importance. Here you can see a wind farm in Germany under a storm. That is a generator acting as a lighting receiver. On the right, we see the damage caused by lighting to the fiberglass material. This damage composes the proper functions of the generator. The ESC standard specify 4 types of protection for blades. We have pointy receiver, as we can see in A and B, which have a ground conductor located internally. In examples C and D, we have the conductor located externally, where in the example D, the conductor is a metallic mesh. In software, we are modeled 4 types of device. The modeled one is a top receiver with a metallic extension on the top of the blade. The 2-spot receiver with 2 metallic points located near of the top and the center of the blade. The model 3 is a metallic mesh, which consists of a strip of the blade body covered with a thin layer of copper. And the model 4 consisting of a joint, the models 1 and 3. The blade was considered homogeneous and made of the carbon fiber. From the equation presented, we can obtain 3 distances used in simulations. These distances vary depending on the current applied. 3 different distances for 3 different currents were simulated, as shown in the table. Was the setup of the simulation. It consists of an airbox with the lighting step leader and the blade. For each current, the distance R was changed. As a result, we obtained thermograms that show the intensity of the electric field per meter present in the blade. We can see in the red the regions where this concentration was higher. It's important to say that these results show us the regions where there is a great possibility of the suffering atmospheric charge. And some conclusions. For 40.5 meters away, the intensity of the electric field was greater in the body of the blade, far from the top, which may indicate a risk of the failure. And however, it's pertinent to note that area of the blade body constituted a relevant part of the electric field. The total or partial coverage of the wide turbine blade with a metallic mesh may vary according to manufacturer's design, and they consider other performance parameters. The metallic mesh concentrated the electric field similar of the Model 3. The sides of the blade also had a high concentration of the electric field. And these are the points to consider when we design a protection system for protection of the wide turbine blade. And I think I finished. Thank you very much for the attention. And if you have any questions, please can ask me.
Thank you very much, Renan, for a very interesting work. The floor is open. If you have any questions, please, you can write them on the Q&A section on the right. ¿Alguna pregunta, por favor, para Renan? I will have a question on my side, Renan. Or what would be the next steps of future work for your research?
I think we will try to make experimental tests to validate the results of the simulations, because in this work we only use simulations.
And do you have identified any turbine field for that?
Sorry, I can't understand.
Do you have available any turbines, any turbine field for that?
We can take a smaller example to test and reproduce the same conditions in a model smaller.
Okay, thank you. Is there any other question? ¿Alguna pregunta, por favor, para Renan? Muy bien, entonces, si no tenemos más preguntas, muchas gracias, Renan, por tu trabajo y presentación.
Thank you.